Lindsay Astro 30 here yet again, and welcome back to AEL. Now if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Got it right that time. On the desk here I've got some PCBs to assemble today. Well, one of them, I don't have to assemble all five. It's a preamp circuit that I quickly knocked up for my test amplifier. I did say when I was building the test amplifier that I may include a preamp. This is it. So this is a single-sided design. I will release the project on PCBWay prior to this video being uploaded if you want to build it, because it's basically a handy little preamp that you can add to any power amplifier. So get the boards out of the packaging. Oh, lovely. I always love new PCBs. It's based on the NE5532, as most of my designs are, and it's a single potentiometer design, so that's the volume pot. It's a 100k linear, and I will show a schematic in just a moment, but basically it's just a single stage amplifier to provide a bit of gain before the power amplifier and giving you a volume control. That's the underside there. That's kind of snazzy. And it has its own DC voltage regulation circuitry on there, so two 12-volt Zenas and a couple of 1K 1 watt resistors, which I'm going to have to go out and buy from JCar because I don't have any. What a bugger. I've got some other parts on order for capacitors and stuff. I've got some of the components so I can build part of it today. You'll notice that here we've got one microfarad 63 volt capacitors there. We've got another two 1 microfarad 63 volt capacitors there, but they're different sizes. Well, it's not because it's a different size capacitor, they're all physically the same size. It's just that I didn't bother modifying the footprint too much. It's because there's a trace that runs up in between those two capacitors of the larger footprint. It just made routing a single-sided circuit board a lot easier. The reason I chose single-sided is because it's a lot easier to remove components, desoldering, to change, to modify things like modifying the gain, for instance. A double-sided board is more challenging to get components off of and clear the holes with conventional methods such as one of these type of solder suckers. They can be a bit of a pain in the ass. I need to invest in a better one. But anyway, so we're going to build this today. I'm going to test it out. But we're going to have a look at the schematic, and yeah, I'll just go through that and we'll get building. Oh, someone's put a large ass keyboard in my way. Okay, so here's the schematic, and I've just noticed that on J2, which is the input connector here, pin 2 isn't apparently connected to anything. The ground wire that I had there has mysteriously disappeared. Should have had a wire going down to another one of these earth symbols just here, but it seems to have buggered off. But alright, I can fix that later, but that's fine. We'll just assume it's there for now. So anyway, we're going to look at this side because this side's identical apart from the power supply. We come in through the input through this 100k resistor to ground, this 1 microfarad capacitor, which I'm actually going to use a bipolar 50 volt one instead of the 63 volt electrolytic. That then goes into this linear 100k pot, one side of it, it's a dual gain, which forms our volume control. And we're using linear because on the wiper side here, we've got this 15k going to ground. So this gives a fake logarithmic taper to this linear pot and gives us the impression that it's actually a logarithmic pot to our ears when it's not. It's based on Rod Elliott's ESP better volume control, which I think is project 1 on his pages. I'll link that in the description anyway, so you can get a better understanding of how it works. I'm using the passive version rather than the active version. That then goes through this 1K stopper resistor that just stops the op amp here picking up any RF signals and amplifying them. from the input stage here. And we have this 10K feedback resistor off of the output of the op amp and this 2K2 resistor going to ground. And that gives us roughly a gain of 5.5. So then that goes through this extra 1 microfarad capacitor going through this 100 ohm resistor out to the output. Now, the reason we're going through this 100 ohm resistor is so that we're not causing the high gain stage here to oscillate when connected to the power amp, because high gain op amps do like to oscillate. So that's the reason for the 100 ohm resistor there. The power supply I've already explained with the PCB. We've got these two 47 microfarad bulk filtering capacitors on the DC input connection going through these 1K 1 watt limiting resistors to the Xenodiode shunt regulators here, and they're slightly smoothed with these 10 microfarad capacitors here, and that provides us the plus minus 15 volts we need for pins 8 and 4 respectively. It's not shown on the second half of the op amp because, well, it's not needed. It's a single device, so you only need one set of power supply components. So anyway, that's the schematic. There's not much really fancy about it. It will give us a gain of 5.5, which should be more than enough to pickle that power amplifier without having the volume control sitting about halfway to get any decent sound out of it of, say, a signal is only like 250 odd millivolts RMS coming in. So let's build the circuit up now, and then we can start testing it. Okay, so that's the schematic out of the way. It's pretty simple. So now I'm going to build up the PCB in time lapse because, well, something to do. I've got all the parts. Well, some of the parts I need. There are parts on order, as I've said. I've got the bunch of resistors off to my left here. It's a mixture of new resistors and used resistors off of other boards that didn't work. So, as I've said previously on this channel, nothing goes to waste. I try to reuse stuff that there isn't really anything wrong with. So that's what I'm going to do. So you can sit back, enjoy, and watch this built up in time lapse. And about 45 minutes later, it's built, except for the pot, and I have not put the IC in yet. There's a reason for that. I had to wait for the parts from JCar to turn up. And speaking of which, I ordered 4 1 microfarad 50 volt bipolar capacitors. I ended up with 3 and a 2.2 microfarad bipolar capacitor. So that means one of these channels would have had extra capacitance on it, which can affect the frequency response. So I had to make a substitution. I had some spare 4.7 microfarad 50 volt bipolar off of another circuit board that didn't work. So I used them on the output side. It doesn't really make much difference, but at least both capacitors are even. And there's an added bonus. They sent me the pot without the mounting hardware, so there's no nut, no washer. Lovely. Great JCar. It's lucky that I've actually got some spare pot nuts for the 16mm pots. Now, I'm going to mount this after I've cut the shaft. That's the reason why it's not mounted. So I've got to do, well, three things. Cut the shaft down on this pot to around about 10mm in length. I've got to leave the dowel pin on so it can locate in the front panel and solder it to the board. I've also got to make up the DC connector for the power, and I've got to open up the test amp in order to connect it to it. And I've also got to remove the power supply and the test amp to put another one of these headers in the DC position, which I didn't do. So that's going to be the next bit of fun and games. So let me get started by cutting this pot shaft down. It's windy as heck out here today. There we go there, the pot is now soldered onto the PCB, and the reason why I've left the IC out is because I want to, after connecting it to the DC power supply, or test amp in this case, I want to measure across pins 8 and 4 to make sure that I've only got like 24 volt there, no higher, within a few millivolts of course, and yeah, just to make sure I'm not going to blow the IC up. Now the next thing I've got to do is I've got to make up the DC cable to connect it to the power supply. I've also got to open up the test amp, and I've got to pull the power supply unit out of the test amp again in order to put the header in on that PCB, because I didn't do it. So I'm going to get about doing that, and I'll come back in just a little while. This is going to be awfully difficult to do like this, but I'm going to give it a try. My soldering iron's tangled up. So I guess I'll just have to do this the hard way. I don't really want to take all the grounds back out in order to solder in one connector. Okay, now I can solder the rest of them. This has been off for a while, so I'm not worried about getting, you know, like a zap from the filter capacitors or anything. They should be fully discharged by now. Well, that's the theory anyway. Whether that's actually accurate is another story. Okay, that looks like it's soldered in. I know you can't see much, but guess what? I can't see much either. Right, so now I can put the PCB back in to the unit and then make up the cable that I need. So we now have a connector. I've got the cable done now. It took about 5 minutes. I'm getting so used to crimping with this tool. It's so much quicker and easier than the way I used to be doing it, which was with a pair of pliers and soldering. Okay, so I've got it propped up on the transformer box, and I have actually lengthened the transformer bolt, by the way. So I want to measure what the DC voltage is at that op-amp socket. Right, so the unit is plugged back in. Turn it on. I've got power. So between pin 8, which is over here, which you can't see but I can. Pin 1's there, so pin 4. 23.64 volt. That's perfectly fine. Alright, so I've got the preamp now installed in the case in place of the volume board, and it might be a good idea for me to stick a IC into the socket, or else nothing's going to happen. I probably should have done this out of the unit rather than in the unit, but okay. Alright, the op-amp's in, at least I think it is. So now it's time for the first power up with the preamp in, and see if it makes any strange noises. Make sure the volume's down. don't hear any strange noises. I don't hear any mains buzz either. There's a little slight hiss coming out the speaker, which is good. I need an audio lead. And I'll just test that. I could have put this on the oscilloscope, yes, but I thought it's just much easier putting it in the unit it's going into to see if it actually works. So I'll give that some volume. I'll touch the end of the lead here. Oh yeah. That's the right channel for some reason. And this ring is the left channel. I've got one of these channels inversed. It's that input connector. I've got the left on the left of screen here, where it should be on the right of screen, so it's in the connector backwards. I may be able to correct that by reversing those two wires around. I'm going to try doing that first. Fiddly process. Just need to get the crimp lugs back out of the connector, which can prove more challenging than is really necessary. That's one. That's two. And all I've got to do is swap them around in the connector, which may prove to be challenging because of the length of the wires. That one just went and reseated itself, which is annoying. I didn't want you to do that. Okay. So that's the left one out. So that one needs to go over this side. And that one needs to go over the other side. So I'll get that one in first, I think. I don't want to have to re-crimp the connector if I don't have to. Sorry if my hands are in the way, but I really need to see what I'm doing. So, let's try that again. This should be the left, which it is. The ring should be the right, which it is. So I guess the next thing is I'll hook it up to an audio source and play some music through it and see, you know, how it sounds. Okay. Okay, it works, and we're not distorting or anything stupid like that. So I've got the phone up, volume up full, and it's not distorting the preamp. So the phone puts that around about, I think it's 186 millivolts RMS out the headphone socket, because it is a headphone socket, not a line out. So that's the reason why the volume control had to be up so far when the phone was connected, probably twice that amount. Before you got any decent sound out of it as loud as it is now. But next thing to do is just to tidy up the wiring a bit, and maybe cable tie a few things, put the lid on and put it back to where it was. I think that'll be fine just like that. That's the DC wires. They're twisted together, by the way, to help minimize any noise that might be inducted like mains hum. That's one way of doing it. So yeah, it's got a preamp now. Nice. As I say, I released the project on PCB, so if you want to build this preamp, you can. It's not just for this project, but it can be for any power amplifier if you only just need a volume control. So, alright, I'm going to put the top back on, put it back up on the shelf, and we're going to close this one out here. And I want to say thank you for watching. If you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying, see ya, have a great day.